players. I hope you're. Hello again, soccer players. I hope you're winning. I hope you're also working on your map. I'm sure you are every night, getting together and working on that map. But in case you needed a little help on these story problems, let's provide some for you. Now I'm talking to Grayson and those guys. Okay, number 20. If the length of the, okay, so we're talking about the width and the length of a rectangle, right? So if x is the width of a rectangle and y is the length of the rectangle, what do we know about the width and the length? Someone get that, please. What do we know about the width and the length and their relationship? Well, we know that the length of the rectangle is twice the width. Pretty simple. We also know that the perimeter of the rectangle is 30. Well, we learned about perimeter of rectangle like right 3rd grade. So that's just, how many widths are there on there? How many lengths? Pretty simple, really, isn't it? Because this one's already solved for you. So all I'm going to do is substitute in, I bet you only did x plus y.
Yep.
See, those are the silly mistakes that I know you guys make just because I know that you just, it's just like another 10 seconds to think and just really think it through. Okay, so I'm going to plug this in. That's okay, just learn from it. I'm going to plug this in for y here, right? Substitute. So substitute that in, and then I have 2 times 2x equals 30. So I get 2x plus 4x, or 6x, equals 30. 6x is 30. What's x? 5. Okay? So guys, those of you out there just like I'm guessing and checking and stuff like that, I get it. That's a good way to check it. But this process is a really important process. This is the learning target. How to write an equation and solve it. Okay? The learning target is not how to get the answer by guessing and checking. Okay, so now that I know that the width is 5 units, it was just units, right? Did it say what it was? No, centimeters. Yeah, that was hard, right? 2 times 5 is. Okay, so not too bad. That's okay. Everybody has their moments, right? I don't know if I call it stupid. I call it a moment where you just weren't quite so focused and dialed in, and sometimes that's why I say put the phone away. Sometimes you guys get distracted by that. Not that. Oh, I think every single one of you at some point has been.
Wait, what you said?
If you have your phone next to you in the middle of a problem and it vibrates and you're like, whoo, and then you check it, the next thing you know, wait, what was I doing on that problem? And then you're like, ooh.
That never happened.
No.
That's never happened.
Never.
I was texting. I keep my ringer on silent and I keep my phone across my
Well, that's a great strategy. I wish everybody did
I
that.
texted get up and get it.
The only way
I make sure that I don't like lose my phone whenever I do homework, so I keep it in my hand on.
That's sad that you're worried about
No,
it.
I
That's not a
don't
good
want to
strategy.
lose it.
That's a
I
terrible
can
strategy.
like put it down.
Okay, you're wasting time. All right,
I'm
so
texting so you don't make the next one.
Guys, they check yet.
so what happens with the morning classes, they didn't realize that there's one really easy way to do this, and that is this. And because they didn't recognize the easy way or take the time to figure out what would require the least amount of work, they made it a lot harder and they made a mistake and they didn't solve it correctly.
I didn't do that, but I want to write it.
It's okay. So I'm going to plug this in for y into the top equation, right? Okay. 5x minus 9 times negative 12x plus 47 equals 29. This is not a 9, it's a negative 9, so I'm going to make sure I know that by doing plus and negative. I'm going to distribute, and that'd be negative 360 plus 63 is 423. Then I simplify. 5 and 108 is 113. Oh, running high.
I got it right. I knew it would do that.
Now I have to not to be in big numbers for Halloween too, not just fractions.
Was this one? Yes.
It's
Two.
a giant fracture.
And integers.
Oh my goodness. Oh, you're doing so
4.
Yeah, now it comes out, all those big numbers come out to be a nice simple. Then I go back to the beginning, okay? If x is 4, Then I plug in 4 for x, and if I go 5 times 4 minus 9y equals 29, I get 20 minus 9y equals 29. Subtract 20 from both sides. Negative 9y equals 9. Be careful, that's a negative. Negative 9y equals 9. Divided by negative 9, and y is negative 1. That's how I get 4 negative.
And now we're gonna do number 32.
But you can see how many chances there were to make a mistake along the way. Yep, 32. I'm handing out the quizzes and we're rolling. There we go. Hey, 32. 4x minus y. Minus 4 equals 0. And 3x plus 2y minus 14 equals 0. So the easiest thing to do on this, and a lot of you are going to be like, ooh, why didn't I think of that, would be to add y to both sides here.
Oh, really? That's what I do. Yeah, exactly.
Right? Done. Now I can just substitute right here. No one should be talking right now. Now I can just substitute right there for y. 3x plus 2 times 4x minus 4 minus 14 equals 0. I mean, I could have added 14 to both sides, but at this point I can do it now. So 3x plus 8x minus 8 or plus a negative 8 minus 14 equals 0. Simplify by combining like terms. 11x plus a negative 22 equals 0. Add 22 to both sides. 11x equals 22, x is 2.
Okay, that's what I got. Got what? X is 2.
So if x is 2, plug and chug back in. If x is 2, I'll just go into the top one. 4 times 2 minus y minus 4 equals 0. 8 minus y minus 4 equals 0. 8 minus 4 is 4, so 4 minus y equals 0. And if I add y to both sides, y equals 4.
Wouldn't it be easier to just say when it's not very solved?
What one?
Great job, so you can study y equals 4x.
Oh, that's a good, actually, Jackson has a good question. Would it have been easier just to plug into that?
Yeah.
What, can you think of something, a wrong reason to plug into that?
That's what I always do.
Yeah.
They're all right.
Because if you actually solve for y wrong,
Yep.
then if you're gonna plug it in, you're gonna get wrong.
If you solve for y wrong and then you plug it back into the thing that you solved wrong for, you can appear you got it right and you didn't. But if you plug into the original equation, you can't make it. That's not going to happen, right? It happens, right? Because if you plug into something you've already made a mistake on, it's going to appear like you're right.
No,
When I came in this morning.
Yes.
And you made the comment.
Okay. All right. So, good job, guys.